OpenAI released Atlas this past week. Have you gotten a chance to play with it yet?
Yeah, I think people were worried that this was basically just going to be a wrapper around Chrome with a little bit of chat fused in.
A little pizzazz.
And that's kind of what it is. Why build a browser in the first place? For me, it's pretty obvious. They're trying to become a search engine.
Speaking patterns break the code, pre-trained pod.
And welcome back to the Pre-Trained Pod, where AI scientists talk shop and talk shit. I'm Pierce Freeman. I've built and sold multiple AI startups.
Hey guys, my name is Richard, and I'm a postdoctoral research fellow at the University of Cambridge.
Richard, it's good to see you.
Good to see you too, man.
Any crazy happenings from the weekend?
It was honestly a pretty quiet weekend. Nothing too crazy. I'm going to be going to China for EMNLP, and hopefully, as part of the pre-trained pod, I'll be able to talk to some people, get some interesting fresh takes that are fresh off the press. Some of the newest research publications are going to be dropping at EMNLP. So I'll be trying to share those with our dear listeners as soon as they're available.
Did they actually give you a visa this time?
I have a Chinese visa. I think that's still valid for 6 more years or so, maybe 5 more years.
Nice.
So I'm good to go. I have at least until 2030, I want to say, on this visa.
After that, all bets are off.
All bets
for
are
the time
off.
being. You're locked
All bets
in.
are off. No, but it's honestly such a nice visa. I think I can go into China 4 or 5 times a year and stay 60 days at a time or something like that. So big up the Chinese government for giving me a pretty nice visa a couple of years ago. I don't know if they're still doing that these days, but we'll see. Hopefully,
obviously they want to keep the AI talent close.
Yeah. Or maybe they're trying to attract AI talent. I don't know. I could go either way. I could see them trying to open up a little bit more, get some more expats working in Beijing. I actually have a friend who moved to Beijing recently to go work in AI. So who knows, man? I feel like there's a world in which the AI space becomes a little bit more of a pipeline between the two, but maybe that's a little bit less likely than the opposite. But we'll see.
We'll see. Well, hey, we're excited to have you as the frontline reporter reporting.
Yeah,
AI.
it's going to be fun, man. And maybe for the next one, you can also come through a little joint interview with some of the presenters and the conference attendees.
Yeah, totally. Amazing. Well, Richard, hot off the presses this week, a lot of interesting news I think we can talk about. We have the long-awaited OpenAI browser Atlas was finally dropped.
Big one, man. Finally.
Yeah, I think we're going to have a lot of things to say. I can't wait for you to weigh in. Pytorch Monarch, which is this distributed computation project from the Pytorch team, a new RL training strategy for agents, evaluating benchmarks for LLMs, and a new way to KV cache in Diffusion LLMs. So half paper, half industrial news.
Amazing. Let's do it. Yeah, let's jump in.
Okay, Richard, I know you are a big browser guy, and you've been waiting for this release for a very long time now. OpenAI released Atlas this past week. It's based on the Chromium rendering engine, but I think it's fair to say the similarities basically end there. It has a native integration with ChatGPT, so when you search things in your menu bar, it starts a new conversation. It has browser use tooling to control elements in your screen, and I think the visuals are stunning, and it feels a lot more modern than the other legacy browsers that I think most people use day to day. Have you gotten a chance to play with it yet? And how do you feel like it compares with some of these other new age browsers like Arc and Perplexity's Comet probably seem like the leaders in the space?
Yeah, I think people were worried that this was basically just going to be a wrapper around Chrome with a little bit of chat fused in.
A little pizzazz.
And that's kind of what it is, a little bit. So in some sense, this is what I expected. It's hard to, at this point, reinvent the wheel. Chromium is basically the browser at this point. Obviously, there's still Firefox, there's still WebKit, but every single browser I've seen is always built off of Chromium. I assume, you're the expert here. You've worked on this stuff much more than I have, but I assume it's because they do a really good job with a lot of the security and safety features. Like building a browser these days is really freaking hard. There's just so much code bloat at this point. Like I think that Chromium actually is 35 million lines of code. Please check me on this, but it's a ton of code that you have to write if you want to basically rewrite a browser from scratch. So it makes sense that everyone's basing their browsers off of Chromium. What I will say is that Arc did a really good wrapper around Chromium in the sense that it feels like they were able to introduce new design elements, like this notion of folders, this notion of spaces that Arc has. I absolutely love it. I've totally drunk the Kool-Aid. I love Arc. I think it makes a lot of sense for me. I actually don't like this return to Chrome that we've been seeing recently with things like Dia. That's the new browser from the Arc group. And frankly, the Chat Atlas looks very similar to all of the other existing AI-based browsers these days, be it Perplexity Comment, Dia. There's a couple of other smaller ones like Brave, I think, has one.
So you preferred both of these browsers are from the browser company of New York. So Arc and Dia. Arc was kind of their OG. And then they did a total pivot, said, hey, we're actually going to stop development on that. We're going after this new one.
At this point, they've been bought out by Atlassian. But yes, I mean, I think they were. Yeah.
Sure. Pre the Atlassian buyout, I think they've said that they're still going to continue to develop the browsers, maybe with some native Jira integration. What did you really like about Arc that you feel like you're not getting from these other browsers?
It feels like Arc was trying to do this thing that kind of Chromebooks were trying to do back in the day, which is to say, when you think about how you use your computer, 90% of it is on the internet. At this point, even if I'm editing a document, I'll be using Google Docs, right? So even as simple as actually writing something, I'll even do that on the internet. I'll need to access the internet to do very simple tasks. So I'm living basically in the browser. The first thing I do when I open up my computer, almost always, is I click on the browser. At that point, the browser is your computer, right? If you're spending 90, 95, 100% of your time in your browser, you have to think about a new UI design language. Or I think at least it behooves you to think about how can we think broadly about the role of the browser in a world in which you're spending 90% of your time in the browser. And what Arc did, their solution to this was to say, let's make the browser look more like your operating system. So let's have there be spaces, let's have there be folders. So now rather than just having a bunch of tabs, you have websites that are inside of different folders. You're navigating around your browser like it were your computer, like the operating system of your computer. And then they also had this realization that oftentimes, rather than actually downloading an application and then using it locally, like on your actual computer, people will write web apps that look like applications. I mean, they're called web apps for a reason, right? They're applications that look very different from just a normal website. And so what they decided to do was, okay, well, in the Arc browser, you can actually pin it to your control panel effectively, and it shows up as though it were an app, which I think is really clever because at that point, it's impossible to tell what is actually a website and what is an application. It's the same thing if it shows up on your browser as though it were an application. So a lot of these design elements are radical and new and fresh, and I love them. But for whatever reason, it seems like a lot of people didn't like them as much. A lot of people I know have been criticizing Arc for a while for being a little too different from Chrome, which frankly, I personally don't understand. Maybe I'm one of these like niche 5% of users that absolutely love the existing UX design language. But I think it's a little bit of a shame to not be exploring with different types of design elements, how you interact with the browser, given the fact that most of your time on your computer, if you're not a power user like us, if you're not really coding, if you're doing more like basic tasks, you're going to be spending a ton of time on your browser. So I think at that point, it does make sense to think about, well, how can we basically redesign the browser? And no one is really doing that as well as Arc.
I feel like Arc always felt like a very experimental browser to me. Like they clearly were going after the early adopter cohort of people that are really jazzed when they see some new functionality come into their browser. I imagine why it failed is because most people just don't want that. Not only that they don't care, but that they actively don't want change to an application that they use every day. And that gets you in kind of in this adoption curve, like crossing the chasm vibes. That gets you a little bit more into the downstream, much larger market of people who are not strict innovators or like early adopters.
Yeah. People just didn't get it. I think that's part of the problem.
I think that was part of the pitch. And this same thing has been tried. At this point, it feels like 1,000 times. I think these web apps come under this idea of progressive web apps, Richard, right? Like the original iPhone before there was an app store, the idea was people would build web apps. Like the whole pitch, actually, now that we have an internet connected phone, was that you could pin websites to your home screen and that those would serve as the application layer on your phone by just compressing a website down to the size that fits your smartphone. And there's a little bit of Apple additional features that it will give you if you flag your site as, yes, we actually support this functionality. Like one, it will give you that home screen widget. And I think it will also remove the Safari border from the top of your screen. So it was very Arc-like in that way, actually going back to 2008. But then I guess at that point, the limitation of the web, the API surface area was too little. So you couldn't really do native things. And it always felt like a little bit too much of a compromise. Like you're not really able to do the interesting things that we want to do on mobile because you don't have access to the full APIs because they're not in JavaScript. But at the same time, it is a mobile app. And once the App Store came out, at least you're competing with applications that can do that kind of stuff.
Right.
So I would be curious to see if Arc was really serious about this vision, or these other browser manufacturers are too. What is the subset of functionality that you can expose as part of a web application that maybe wraps APIs that are part of the desktop itself, but that aren't in a conventional web specification? And it feels like maybe because Chromium is the underlying browser for all this, no one's really tried to make that hybrid. But I do think if you crack the code on that, to be able to get a web app that is legitimately an Electron app, which can bridge both these JavaScript APIs and these native APIs, I think there could be something there around really cohesive, compelling, fast, performance optimized web apps that could be desktop too.
At the UI level, I think I agree with you. I think there's a deeper level, though, of redesigning the UX experience that the browser lets you do. And maybe here we can talk a little bit more about what OpenAI is doing with Atlas that's so unique. So far, when we've interacted with these applications, they felt somewhat personal in the sense that you can write with them and you can have a long context and a long session sort of window with these applications. If you're talking with chat, you can basically keep having more and more discussions with it until you hit the chat sequence window length, right? I think that's probably on the order of a couple 100,000 tokens now. What's been missing is this fact that you want your models to be personalized and to really understand who you are. And you can do that by exposing your entire internet search history to these apps, which sounds scary on the surface, and it probably is actually scary. And we'll talk about why that is a little dangerous in a second. But I like the idea broadly that in order for these applications like Chat, like Claude, to actually be able to understand you, one way of doing so is by creating the environment, the ecosystem where you have to interact with Chat via the browser. And it gets to really know who you are by looking at your interaction histories with different websites, what kind of stuff you do on the web, what are applications you tend to use a lot. So I think that makes sense. Like they're building out this new ecosystem to really get to know you as a user in a way that Claude hasn't done yet, right? Because Claude doesn't have a browser. And so it's really hard for them to compete at that same level. So I think at that level of the user experience, they're doing something interesting here. I wonder if they combined that somehow with what we're talking here about how Arc feels somewhat fresh, if there's some sort of a synergy that you can create. But I don't know. It is like a new interesting step forward in how browsers, what the role is, how they interact with AI models and the interface between those two things.
Yeah, I've got to say, it's still a little unclear to me how this is going to fit into the overall ecosystem, or which interaction paradigm is going to actually pan out over the long term. Because in terms of like browser use and browser control, OpenAI has two different things now. They have the computer and browser use that you can do on chatgpt.com outside of Atlas, and they have the computer use that you can do inside of Atlas, right? If you ask ChatGPT to go to some website, do some research, or even fill out a form for you, make some action on your behalf, it can do that in the cloud by just spinning up a VM and executing those same tasks, right? Like it's had the support for being able to launch a Chromium session and do things for a while now. And I think the way that they're doing that behind the scenes is they're actually spinning up an X11 session, like virtualizing a desktop and letting ChatGPT and their agent click around and type different things within that session. On the other hand, you have Atlas that's basically doing all of that same functionality, but just on your local browser. And I guess the benefit is that then you can actually see what it's doing, both if you need to supervise it, as well as, I don't know, like if there's some task that maybe it can do 50% of well, but then the other 50% requires your intervention. But there is an open question in my mind about, is the right interaction paradigm here to have something that is spawned async in the cloud, or something that's effectively synchronous that you're blocking on your local machine?
No, I think it's totally different. I think this is a totally different product. I mean, basically, what they're saying here is we want to record everything you're doing all the time. And that way we understand who Piers Freeman is. Like, if we can just interact with Piers Freeman, not for the 30 seconds where Piers opens up OpenAI and types in some chat stuff, right? If we can be looking at what Piers is doing for the 12 hours a day he's working, now you finally actually can build out a full personalized sort of understanding of who you are. It's not just that you're interacting with chat, it's that chat is storing all this stuff about you, is storing like a memory. And I think they actually call it memories, right? of who you are, what you do, what you care about. I think that this is basically a way of creating this kind of like personalized embedding or this notion of who you are in a way that's been a holy grail for a long time for these LLM manufacturers.
Yeah, it's funny, right? Because on one hand, that is actually the pitch that I think is most compelling or most differentiated, right? Even down to if you're doing the same action repeatedly online day in, day out, like I always start my morning by going to the New York Times and Hacker
Yep.
News for
Yeah.
30 minutes. If it's able to identify that that's a continuous pattern of yours and then suggest an automation, I mean, that is seen as like the holy grail of robotic process automation, right? Like proactive creation of shortcuts that are going to make your life better. I think my caveat to that is they don't really seem to be leaning into that direction versus the computer use stuff, right? And
Mhm.
maybe that is just because the pitch of the product is the computer use stuff. So eventually they can get the emergent properties of everything else, like the observational data that they're able to cultivate and use that to personalize to your behavior. But in terms of the overall tech stack that they're supporting here, in my mind, right, the root of it is Chromium, which is
Yeah.
providing both like the V8 engine, which is a JavaScript engine, and then the browser renderer. And then the application layer on top of it, you've got the functionality to talk to ChatGPT by typing in your search bar. That's like pretty trivial to implement. You've got being able to pin it on the sidebar. You've got the agent able to then communicate with your browser session. So opening up new tabs, looking at the DOM element, clicking around. That fits in the computer use stuff. And you also have this logged out mode, which allows you to avoid sharing your site credentials. Kind of like opening up a tab in incognito mode, how that
Mhm.
clears out your cookies. You can let the agent operate in kind of this like isolated sandbox, so it doesn't affect any of your page states that you might otherwise have logged in applications. And then it has these memory things that just feel like a bolt on to me. I mean, I don't know if that's a good way of approximating what their actual priorities are here, but as I'd think through a dev roadmap, I'd be like, okay, they were building this browser. It's a pretty small team. Let's say that they spent 6 months on this. It feels like they spent maybe a week getting the Chromium engine working in their own custom pipeline. They spent maybe 2 days integrating ChatGPT, and they spent 5 months on browser control. And then they
Yeah.
spent 1 week in the last week on this personalization stuff. And again, I don't know. I think like what you're saying, I agree with and I think is interesting, but I guess I'm not really convinced that that's actually the direction that they care the most about here.
I don't know. I think you might be overthinking it here. I think, frankly, let's build out this web environment so that people actually want to start using our platform and then we can collect data on them. And then later we can figure out what we want to do with that data. Number two, why build a browser in the first place? For me, it's pretty obvious. They're trying to become a search engine, right? Everyone is. Everyone's trying to compete with Google. Already, Google is quaking in their boots a little bit, right? They're worried that for the first time in like 20 years, they're really getting competition at the level of the search engine, like their baby, right? And to have a browser makes a lot of sense. Like that is how you access the internet. That is how you do search. Obviously, right now they're still relying on Chromium, which is bad, probably. Strategically, they'll probably want to build out their own version of Chromium at some point, but it's the first step. And they're starting to spend money on this. They're starting to do the R&D. They're starting to build out the product team that's working on this. To me, it's strategic. It's a long-term vision that they're trying to do here. It makes sense. This personalization stuff, they're collecting data. They don't really know what to do with it, but it's obvious that it's going to be important, right? It can't not be good for them to collect data on their users. Whether that's good for us as users is another open question. And actually, I think I want to talk to you about that on Thursday when we do our little deep dive on browsers, but I won't say more about that for now. But it's cool. I mean, I think it's interesting. And I think that there is a little interesting ecosystem now being built up and this kind of battle between these different browsers. And it'll be interesting to see how these different companies that have basically the same product are pitching themselves and trying to carve out a little niche,
Yeah.
even though it's so similar fundamentally.
Agreed. Maybe the last thing I'll say on this, since I know we're talking about it more in depth on Thursday, is I think you have to have a very compelling, specific value proposition to shake people loose from whatever the incumbent browser is. Right?
100%.
And in the case of Chrome, back when it was mostly the Chrome versus IE incumbent days, where Chrome was the upstart versus IE, IE was this legacy, slow, really crufty. It didn't really subscribe to web standards. It was all about this ActiveX thing, which was really only in Microsoft browsers. It was bad. And people associated that with their day jobs, which was a bad experience using these software applications that were super unoptimized. Chromium emerged in that fold and obviously has grown a little bit more bloated over time, but I think it's actually still pretty fast. Like, I don't think the complaint that people have with Chromium is that it's a slow browser. It's a resource hog, it's a memory hog. It's like pretty technical things that we wish they would do better. I'm really interested to see if the integration with ChatGPT is a killer enough feature, or some of this computer use stuff is a killer enough feature that will encourage people to adopt the browser that then starts to feed this personalization feedback cycle. I think the thing that's difficult with personalization is until you have it, people won't notice. And the promise of personalization usually isn't enough to convince people to try something new when the payoff is going to be measured in weeks or months of doing something, right? So I think in my mind, it's still a little TBD what the killer feature of Atlas is that's going to convince people to switch. They seemingly want to make it this computer use stuff. I'm not yet convinced that that is better in a browser versus just handling it in the cloud, but I guess time will tell. Okay, Richard, Pytorch released a beta of Monarch this week, which is a coordinated engine for training across multiple machines. Vanilla Pytorch really shines, in my mind, when you're running within a single host. So you have multiple GPUs attached to the same centralized CPU, and you're running your script, your logic within that CPU, and it's calling the GPUs. But at least I found whenever you have to coordinate across multiple machines, you usually have to delegate to something like DeepSpeed, Slurm, or another cluster coordinator to make sure that all these hosts are working on the same tasks. Monarch is pitching itself as a solution to that. So basically, you just write a single Python file, import this library, and they'll handle the distributed systems problems for you. Can you maybe explain a little bit more about how this fits into the existing ecosystem of solutions and where it ends up being different or maybe a better developer user experience?
Yeah, to me, the holy grail of a distributed cluster is, let's say I have a cluster where I have a couple NVIDIA chips, a couple of CPUs, a couple AMD chips, a couple Dell chips. And wouldn't it be nice in the future if I could basically just take my model and use all of that compute simultaneously? Like, it doesn't matter if this is an NVIDIA chip, if this is an AMD chip. I just want to use all of them and have one thing that I can just send my model to, and it just does the right thing, and I train my model. So far, that has been an absolute fairy tale. Like, that world doesn't exist. It's an absolute shit show out there, frankly. And one of the reasons that everyone is so bullish on NVIDIA is because they've won the battle so far, basically. They have this little monopoly where it's really fun to use NVIDIA as long as you only use NVIDIA. And it's basically true for all the different chip providers too. Like, everyone is trying to build their little walled garden. What Pytorch Monarch is trying to do is try to make it a little easier for you to basically take a step towards making this dream a reality of being able to use different chips. One first way of doing that, and I gotta say, I haven't used Pytorch Monarch yet. I haven't needed to use it yet. But as I understand it, the idea here is that basically when you use Pytorch Monarch, you can basically coordinate, okay, if I have different heterogeneous compute, as I guess what you would call it, when does my model run on these different compute nodes? So you can say, okay, well, I have this model, I have it spawned on these different NVIDIA chips and AMD chips, and I now want to be able to have the option to say what part of the model runs on what chip. I want to be able to coordinate that. This lets you do that. But in no sense does it actually fulfill this requirement that we would like to have, which is to say, I just have all this compute. Let me throw my model at it and let me just get the right answer back, right? That isn't what this is doing yet. It's a step in that direction, but it's not quite fulfilling those requirements.
I feel like maybe the right way to think about this at the moment is a little bit more akin to multiprocessing, like the module in Python where you can call multiprocessing.process and then use that to spin up X different processes where you can do a join once they're done. And then you can also talk to them in the middle. You can have some intra-process communication between two different things. But for the most part, you're operating these as a pool of resources that you want to delegate to and then talk to them over some protocol. I think that's what Monarch's doing, with maybe the slight difference that you can both do that across hosts, as well as it's a little bit more geared to numerical processing in the sense that you can have a tensor that's just stored in Python and then distribute that, shard that tensor to different machines in a way that's basically just using the Pytorch syntax.
You still need full control, basically. This gives you the full control to do it, but it doesn't do it automatically for you, right? This is almost like very low level in some sense.
I think totally. Yeah. This is giving you the primitives that then I imagine the rest of PyTorch might incorporate in order to let you do this without even having to think of it. And I think that that in part is the holy grail, right? Like when you're
100%.
designing an API surface area, especially for developer tooling, there's always this balance that requires some trade-offs of you want to allow people to do almost anything because there's going to be some users of yours that will outgrow your default stack or that just want to off-road and do something else. You want to support those people, but you also want to support the early adopters or the simple use case where you say, in 99% of situations, you're probably going to want to do this. Much like the Pytorch Lightning to the Pytorch ecosystem. It's like the majority of ML projects that are not LLMs will need a regular trainer, will need some logging, yada, yada, yada. You want to provide that, I think, is like the default experience. But the only way that you convince people to use that is if the pro users know that there's an escape hatch where they're going to eject out of that at some point and then do something more manual. So I think PyTorch here seems to be building out the very low level stack. And then they're probably libraries or maybe themselves will build off of those primitives in the future once they've stabilized
that makes sense.
what is the surface area and how are we actually doing the low level systems distribution tasks.
Yeah, makes a ton of sense.
The one other thing that I'll add that I think is pretty cool here is that they have built-in fault tolerance, which most of these systems don't have out of the box. Even with multiprocessing in Python, there are reasons why you have your process crash. Maybe it's an exception from your code, but maybe it's an exception from some code that you call. Maybe it's actually the C Python itself crashes. I feel like whenever I am not just operating in a single process, there's always a host of these situations.
Yeah, it gets way harder.
Processes just fail over time. And I do think that the cool thing that they're trying to build in here is saying, we really want you to think of doing software engineering where the failure handling is a little bit more like a primitive that we're going to call for you versus all this layering that you're going to have to do in your own business logic in order to make sure that it can recover over time. Because it's acting as this very top-down coordination layer, I think it's able to handle that in the centralized code and then just treat these separate nodes as workers where they're going to report some status. And if that's an error, fantastic. Let's just restart them and then try from scratch. So I think that's actually a call out function here where if they're able to further develop that, is going to leave a pretty big impact.
Yeah, that would make a big difference too if that can catch kernel errors. Because oftentimes those things are what caused the crash in the first place, but then it's really hard to debug what's going on. If you're doing any DDP or fully distributed training, one node crashes, it's really hard to figure out like which one crashed, why did it crash, what's going on. If it can
what data did it have on that node?
What data did it have? All that's an absolute nightmare. So if we can do some of that, if we can do some a little bit more of like fault catching, fault tolerance, that's really cool.
I think that's what they're trying to do. We'll see if it sticks. I've always been surprised that Slurm has managed to hang on for this long.
Oh my God, I hate Slurm, dude.
Hang on,
it's the worst.
Slurm's the worst.
Oh, Slurm sucks.
And yet it won. Cool, Rich. So there's a new RL training technique in town. It's called SALT. And I'll let you talk more about it, but it effectively creates a graph of partial rewards over time. So most RL systems just observe the end state of some given action that you're doing. So you give it a reward or you give it a penalty at the very end, or they're forced to train some critic model, which can give intermediate feedback along the way. So fully separate model that's able to piece out that feedback and ramp up to the final reward that you give it. Salt has intermediate rewards, but doesn't need to train a critic model, yet it can deliver similar performance to RL approaches that do create a critic. Maybe it'd be worth starting at how regular GRPO works, which I think at this point is one of the more commonly used RL techniques for LLMs, and then expanding that here to why SALT is different or interesting.
So reinforcement learning, the idea here is that you're training a model to take actions for you. So typically, if you think about a classic setting for reinforcement learning, like a robot, the action model is telling the robot, go left, go right, go forward, stay in place, right? When you're doing this for language models, the actions are more along the lines of what text to generate, when to stop sort of generating text, right? These sorts of things. So typically in reinforcement learning, you have this action model, and then you need some way to evaluate, okay, how good is my action? So you have some sort of a critic is typically the idea here. And the critic will tell you, well, having looked at the action that you took, let me tell you how good I think that is. So usually you train these two things in parallel. Things like PPO train these two things basically in parallel. There's a couple of tricks they use to make sure that the actor, so the thing that's taking the actions, and the critic train in a harmonious, compatible way. Now, recently there was this paper that showed that you actually don't even need to train these two models. You can just train one model, one sort of action model. And the big insight here was that if you just train one model, you can train that model to output 10 different things or n different things at once, and then rank how good these things are relative to each other. Okay. So now rather than actually having a model that says this output was this good, you can just do the simpler task of saying, given these two outputs, which one is better, right? And that is the idea of GRPO. The issue with these is that typically when you are doing GRPO, you evaluate these different outputs relative to each other once you've output the entire sequence of words, or if it's a action model, the entire sequence of different actions that agents have taken.
Or if it's a thinking LLM, you'll have to do the thinking tokens, the answer, additional thinking tokens, the answer. It's not going to be for maybe thousands of tokens in the future.
Yeah, exactly. And so you basically, within this output of this thought process or this action process, you want to be able to say, these actions were good, these actions were bad, and penalize them accordingly, right? Even though the final answer might be correct or incorrect, even within an incorrect answer, there might be a good thought process, or even in a correct answer, there might be an incorrect thought process. And so this paper is basically letting you penalize those things at a more fine-grained level and add that into the training objective in some clever way.
Yeah. So can you maybe talk a little bit more about that intermediary process? Because the thinking at some point, I feel like, was if you're able to get the reward for the model closer to actually when the behavior that you wanted to reward happened, that the model would be able to back prop that more easily into its learning paradigm, right? Like the problem with waiting for thousands of tokens to go through is that one, the gradients are going to be infinitesimally small if you have to like really backtrack all this way. And also that you just don't really know. Like even if you were giving a human some feedback, if I soliloquy for an hour and then you say, hey, something that you said in there was really good. Good job. I have no idea what I just said that was actually good. You know what I mean? And like that's kind of the fidelity of feedback that you're getting if you're just giving something at the end. Like, why do you feel like Salt is able to perform so well in these intermediary feedback stages if it doesn't actually have a critic model that was trained in order to do that task?
So Salt isn't a model. What Salt
Sure,
is
Salt's
just
a process.
it's a process, it's an algorithm, it's a strategy. What it basically says is, let me look at all of these 10 different outputs relative to each other. There's going to be a ranking, but then we can see of the ones that were successful, what are some similar thought processes that occurred in each of them? And of the ones that were not successful, what are some thought processes that they had in common? And let me group those things. Let me try to aggregate those things to then naturally surface, what are good behaviors or what are sort of good thought processes and what are bad thought processes. And then let me penalize those individually. In addition to the normal GRPO process, which is just to rank these different outputs relative to each other. So it's basically like in addition to the existing model approach. And the nice thing about this is that because it's not like a model you're training, there's no Salt model. It's just a way of grouping things together. You can apply it to any flavor of GRPO. So any sort of fancy GRPO variant, you can just add Salt to it and it'll work a little bit better.
Like Arlu.
Yeah,
You could just
exactly.
pipe Salt right on the top.
Just throw a little salt on that,
The only thing that I'll probably throw out there at a technical level, I think it was a good paper. It was pretty interesting concepts, is basically what they're doing here is within all of RL, the goal is to try to come up with this definition of the advantage of like, how is this one example or has this one model output advantaging itself relative to your reward score that you've given it? And then Salt's main contribution here is the notion of a trajectory level advantage, which is what Salt is using in order to do its computation, right? Isn't that kind of part of the parameterization that it's giving into this model?
Yeah, I mean, the way that this worked was that GRPO was the big realization that you didn't need to train a separate model. That is much, much bigger, I think, in terms of the impact it's had on the field than Salt. Salt is sort of like this little nice addendum to it. But the notion that you don't actually ever need to train a model that says this is this good, this is that good, that's pretty huge. The fact that you can just have one model. What Salt is then saying is that once we then have a model that just produces text and can rank text relative to each other, is there some way that we can figure out a smart way for it to say, okay, of all this text I've produced, let me figure out what parts of it led me to get to the right answer. And let me chunk those and let me give you extra bonus points if you included those. Or if you included something bad, but you still got the right answer, let me actually penalize you just a little bit. And that's all that's happening here, basically. You don't really need salt for this to work, but salt is just nice.
I also saw that some areas in which salt was known to definitively overperform were on smaller models. So ones that they benchmarked at 1.5 billion parameters, so I guess small-ish, sometimes exceeded larger models when salt was applied, but not when GRPO was applied, which is also an interesting insight or observation. Like this additional guidance that you're giving the model in the interim potentially helps damper down some of the noise that is otherwise outputted by these small models and steer it to the correct chain of reasoning pathways. I thought that was pretty interesting. Yeah, we'll see if this sticks. I think that there are a lot of RL announcements and modifications of the most well-known algorithms for doing RL, and I feel like for the most part they fall by the wayside. Like for a while, RL was increasing in complexity, and I think that culminated with PPO. And then GRPO is a simplification of the PPO process. Salt is now getting a little bit more complicated because you have to both implement GRPO and now the salt thing. It seems like the trend in RL paradigms is actually that we're seeing a bit of a simplification over what we once had. So I'm a little bit more inclined to say that the thing that's really going to stick post GRPO is probably going to be integrated within the RL training loop itself. But maybe we'll borrow some of these salt concepts and can get rid of some of these Greeks because it's simplifying the assumptions. We'll have to see.
I think that's right. Yeah, I think you're absolutely spot on.
Cool, Rich. Well, staying on this paper thread, we need some way of actually evaluating models trained in this RL setting. Here comes Hal, not to be confused with the one out of 2008 Space Odyssey. It's a new project out of Princeton that provides a centralized harness to evaluate AI agents. Note, agents here and not standard one-shot LLM calls like a lot of benchmarks still end up doing. So here in the agent setting, we really care about the intermediate requests, like how many tool calls did they make, how long did they take, what were their reasoning tokens, and what's the accuracy. But it's a slightly more holistic scoring mechanism than just looking at accuracy alone. What are the benchmarks saying about how well the models are doing right now on this HAL score? And do you think something like this actually has staying power or will immediately get out of date the second that some new benchmarking techniques come out of the fold?
Yeah, so let me just start by saying this paper came out pretty recently. The group and the benchmark has been around for a while. So I've known of HAL for a while now. And this is pretty common. Like, for instance, the Hugging Face folks, they wrote a paper maybe 3 or 4 years after Hugging Face was really a thing, right? The Transformer paper came out 1 or 2 years after people were actually already using it. So this is a delayed paper. This has already been around for a while. This isn't new per se. What they were able to do here was take all of their existing findings and their approach and really synthesize it down into one nice paper. I've liked HAL for a while. HAL, when it first came out a couple of years ago, it was this cool benchmark that paralleled a little bit of what folks at other universities were doing. Cicerina, famously, I believe that came out of Berkeley, if I'm not mistaken, was pretty exciting. The folks at Stanford have come out with a bunch of different benchmarks. This, I think, was Princeton's sort of proposition to the field. And they really focused here.
Every university needs their own benchmark.
Every university needs their own benchmark, and every university
their citation style. We need an MIT, we need Stanford,
exactly.
We need Cambridge.
Exactly. Yep. And everyone is sort of creating a little niche for themselves. So whether that'll actually be successful or not, it remains to be seen. There have been a lot of benchmarks that have come out of many other universities that have gone away, and sometimes they go away because they actually are beaten completely. So HAL here, unlike many other universities, they have this benchmark. It has a lot of sticking power. And it's been interesting because they've created an ecosystem. So when you create a benchmark, the way you get a benchmark to stick around and be interesting is by creating an ecosystem where it's easy to contribute your model and submit it to this benchmark and adding to the benchmark. And HAL has done this really good thing where it's pretty easy if you have an additional model to contribute where you can easily run their code. It automatically gets uploaded to Hugging Face as an additional submission. They have a nice leaderboard, and you can also submit another task that becomes part of their benchmark. So they have this really nice ecosystem where it's not a static thing. It's dynamically growing, ever evolving, and they've had a lot of success with it. One of the big things that they've done here too is to make it easy for you to run cluster environments for these different agents to perform tasks on your model. So because we're dealing with agentic models here, the models have to be able to do a bunch of stuff. They have to run in a little closed environment, be it a Docker container or a VM. And they've made it easy for you to do that. And oftentimes, getting that set up is 80% or 90% of the hassle of running these evaluation benchmarks. So they've done that, and out of the box, it's relatively easy to use Hal. And that's why people like Hal, I think, is because it's actually easy to get started and like use. Evaluating agents is notoriously difficult, and Hal makes it a little easier to do that.
I mean, I feel like you've said many times that a benchmark is almost only as strong as how easy it is to call the benchmarking harness.
100%.
Because
Yeah.
if it's an impossible benchmark, even if it's a good data set, it's going to require you to build out your own custom evaluator in order to run it. And of course, like you can do that, but I think that's actually less statistically significant or less academically rigorous, because the second that you're introducing code that you yourself have written to evaluate against this benchmark task, I feel like there's a chance that there are subtle differences in the pipelines that you wrote versus some other paper, especially if you have like heuristics and post-processing that you have to do. It feels like a nice thing about Hal is that it established a very clear model contract to say, we definitely need access to X, Y, and Z parameters. So in Hal's case, you know, the length of the reasoning tokens, the amount of tool calls, accuracy of the model, which you can get by taking the output and then running it against an evaluator. I think because it only needs access to that, and that's both what the cloud APIs provide, and then any locally running model is just going to be a superset of that cloud capability. It really allows you as the model creator to keep using it persistently over time. I think the only question is if those benchmarks end up being beaten, or maybe that falls out of favor, like that specific optimization criteria, then I could see how falling out of favor with it. But if they're able to keep the arena of benchmarks up to date, I can't imagine we're going to deviate too far from that API protocol. At this point, it feels like tool calling, thinking outputs, that kind of thing is basically here to stay. That's as close to a primitive as we really have right now.
I think you're right. Yeah. I mean, I have to confess, I don't work with agents, so I've never actually evaluated on Hal. But one of the main criteria for whether or not a benchmark is successful is continued submissions to the benchmark and updating leaderboards. And Hal's tends to be pretty up to date. So there will be new submissions and the leaderboard will get updated. The benchmarks you never want to use is where you go on the benchmark leaderboard website and the last submission was from like a year and a half ago.
Yeah.
That's
last
the death
updated in
nail.
like July of 2024.
There is a whole art to how you make these things stick, how you build a community around it, how you run a Discord channel to make sure that everyone knows whether the benchmark has changed in any way, there's new additions to it. All this is important, and Hal does a pretty good job of maintaining and fostering a community. And I know it sounds silly because we're engineers and we don't sometimes care about these little details, but it's so important to build this community aspect for these benchmarks. It's hard to stress enough. A lot of this stuff is purely social engineering, and they've done a pretty good job of being sort of like the de facto AI agent benchmark.
Well, it also does go to show that I think that there are two different ways of coming out with these model comparisons. One is for the lab to just run it themselves, which in theory they could do, right? Like they're not relying on any proprietary reporting as part of the big labs to contribute to this benchmark.
Yep.
But then they would have to pay for the compute themselves. Or if you can become enough of a standard that people want to become ranked on the leaderboard because that is good for credibility of the model in the research group, then it's that lab that you're shunting over this effort to, and you're also shunting over the cost capital associated with it. So you can probably get more accurate, or you can get more benchmarks than if you had to piece out some grant funding across 50 different models, especially as we see the rate of models increasing, and it feels like there's a research group out of Shanghai every week that's coming out with some new architecture, a bunch of quants training LLMs now.
Mm-hmm.
It really helps to have one central thing that people feel incentivized to all contribute to, because otherwise, I mean, there's just no way that a research group is gonna be able to stay up to
makes a
date.
big difference. Yeah.
Agreed. I think one thing that they found that was pretty interesting and unexpected was that higher reasoning effort actually reduced accuracy in the majority of runs. So I feel like we've seen and even talked about this insight a couple of times now, where just because you think longer, you know, your model spends more thinking tokens trying to consider some output, that doesn't necessarily increase the accuracy of the answer that it's eventually forced to give you. In some cases, it actually lessens the accuracy that it ends up giving you. And I don't know if there's some deep truth in this. I've always suspected that it's just a question of being out of distribution with these given examples. Like the way that we actually train thinking tokens as much as we do is we have human experts narrate their own thinking patterns when they're tasked with solving some situation. And then we're feeding that situation into the training data alongside their own human curated thinking tokens. And that's what results in the output. And it feels like this artificial notion of being able to set how many tokens you want it to spend thinking and have it continuously loop until it achieves that limit is maybe serving as out of distribution of what people do. Where if some human expert at maximum has written 100 words explaining their thought process for this, and you're suddenly forcing the model to give you 1,000 words.
Yeah, it doesn't have the understanding of how to produce that much content.
Totally.
Basically.
Yeah.
Totally.
It might just be gibberish. And then at the very end, it still has to attend over all of that gibberish. So I wouldn't be surprised if accuracy drops down in that case, because it's just attending to things that are irrelevant at that point.
Yeah. I mean, this goes back to that Apple model that we talked about maybe like a month ago, 2 months ago. This finding is pretty standard now. It's interesting that more solutions to this sort of trivial seeming problem haven't come out. Maybe we can talk about hierarchical thinking models, which is maybe one solution to it. But it feels like to me, this is a data problem, which is what I'm hearing from you. And I agree with you. I think fundamentally it's a data labeling problem. And data labeling problems, the silver lining is that you can correct those with better data.
By throwing money at the problem.
Yeah, you can throw money at the problem, right? So I'd be curious to see, has anyone done this? Can you create a more broader distribution of human labeled thought processes that maybe make the model a little bit more robust to these sort of like out of distribution problems that we're talking about here? I don't know. I mean, we'll do some research and maybe we can cover that in a future episode.
Cool, Rich. Well, the last thing that I want to talk about on this show is the elastic cache. So now that we have our ML models, we obviously want to speed them up. So this elastic cache model has the cheeky title of Attention is All You Need for KV Cache and Diffusion LLMs.
Classic title.
Amazing, succinct, pithy.
You shouldn't be allowed to say attention is all you need anymore. Like,
I do feel that.
I think you should get banned from like the next 2 conferences if you throw that in your title.
You need to start shopping that around at EMNLP. It's clear to me that they just want to compete for the SEO that the original 100%. Paper got, and they get some of the long tail. But anyway, in a text diffusion model, it's a setting where you're not generating one token at a time autoregressively, right? Which means that you have to choose as the model or as the model creator which tokens you're going to choose to generate or regenerate in each iterative pass you do over time. Basically, in this paper, they propose that there are different parts of the KV cache based on a policy of invalidation that then allows you to selectively change some tokens versus other ones at a time. Depending on how much they're shifting, you can look at their embedding meaning. So I was hoping that you could explain this paper, Richard, and maybe we can start by why this can only apply to diffusion LLMs and not regular standard autoregressive LLMs.
Okay, yeah. So a standard autoregressive LLM. Why is it called autoregressive? It's just a fancy word to say you're producing text from left to right, one token at a time. Diffusion models don't do that. The big insight here is that if you take a bunch of gibberish, what if we just change all of the words a bunch of times by a little bit? And let's do that over and over and over again until finally we've rejiggered the words so much that we hopefully have some actually good English sentence come out. It's kind of like an Etch-a-Sketch, where when you sort of like jiggle enough times, it goes back to white, right? But imagine like the opposite process, where if you took a white Etch-a-Sketch and you kind of shook it a bunch of times, you could get a picture of of an animal or whatever, just magically emerge out of these little black dots, basically. That's what a diffusion model is. Now, this works very well for vision models. It's been hard to do this for text models up until a couple of years ago. And then there was a pretty big breakthrough. Now, there's different types of approaches for how to do this for text models. The classic one, and the one that they're talking about here in this paper, does this sort of non-continuous diffusion approach where you have these different mask tokens. So basically you start off and sort of most words are masked out, which means you have no good sense of what word that mask token should represent. And then over time, as you keep shaking this model, metaphorically speaking, so as you keep iterating through this model, more and more of those mask tokens will unveil themselves to be the correct
This
word
is like
that
the
you want them to
classic
be.
text diffusion. Yeah,
Yeah, exactly. And so as I said, there's many different flavors of this. This is just one flavor of it. And I think it's the classic one, as you've mentioned. Now, here's the issue. How do you do KV caching with this diffusion approach? So you're shaking this model a bunch of times. Ideally, you'd like to incorporate the benefits of a KV cache, which is that you don't have to recompute the similarity between different words, like the relation between different words. You'd like to store that in some kind of like a cache, right? But how do you do that when, as you keep rejiggering this model, more and more words become unmasked? This KV caching approach, in some sense, is almost incompatible with diffusion models to begin with. So you have to create some sort of a heuristic.
And the reason why is because the KV cache is effectively a prefix cache.
That's right. That's right.
Like you can cache at any length of that prefix so long as the prefix stays the same. So
exactly.
if you have 1,000 tokens in your KV cache prefix, if the second 500, so inclusive 500 to 1,000, if those change, you could still grab the first 500.
That's
You're paying a penalty, but there's still something. The issue with diffusion, is if you invalidate the very first token, in theory, you've nuked the entire KV cache.
Yeah, well said, well said. I mean, KV caches were made for autoregressive models. They weren't made for diffusion models. So how do you make them work for diffusion models anyway? That's what this paper is showing. And what they say is you can make it work anyway by basically applying a heuristic that uses an attention module to decide when do we recompute the KV cache and when do we just leave it as is, even though it might be wrong at that point. In theory, the right thing to do is recompute it every single time because words are changing left and right, right? But what they're saying here is actually, guys, it doesn't really matter that much. We can learn an attention module that tells us, okay, now it matters and now it doesn't matter. And that's basically the TLDR. Attention is all you need for this diffusion KV caching approach. That's the high level takeaway. The actual specifics are somewhat interesting. So basically this works at 2 levels. You can think about this as like an X and Y axis, where on the X axis, it's across time as more and more words are being, in diffusion model diffuses all words at once, but you can decide when sort of at what point in the word sequence do you want to rejigger the KV cache, and at what depth do you want to refresh the KV cache. And so there's these 2 components, and so for both of those components, they apply different types of attention mechanisms to decide now we should refresh this KV cache.
And the depth that we're talking about here, Rich, is because in most of these transformer networks, there are multiple transformer blocks, if you want to think about it that way, that kind of stack to like higher order representations, and each token has to pass through those different tokens before it finally reaches the output.
Yeah, the depth, like if we say a depth n diffusion model, it just means that the n times you're going to be diffusing the model. You're going to be shaking up the model basically and trying to get some better words produced, right? That's all that it is. So in some sense, like the more you diffuse, the better, but you're also paying this computational cost. Right? Yeah. Each time it's expensive to do this operation. And that's all there is about this paper, frankly. I thought this was pretty interesting. I would be curious to see if it is actually as impactful as it seems to me. I think this actually is a pretty interesting paper. The fundamental issue here is, are people actually going to make diffusion models as mainstream as I think people want them to be? I think researchers want this to be a reality where we're going to be using diffusion models exclusively in the future because they're faster, they're interesting. In theory, they have all these nice properties. In practice, is that actually going to be the case? Is GPT-5, GPT-6, GPT-7, are those all going to be diffusion models? Probably not, right? I think probably there will always be some element of autoregressive language modeling in any model we use. Now, maybe there's a part of it that does some diffusion step. That's completely possible. But I don't know whether this is actually going to be as impactful as we might hope it would be.
Yeah, I mean, I think there's another component about this too, is this is not a trainable approach, right? Like much like the KV cache is this mathematical operation you can do really for free in the KV cache case because the linear algebra just reduces to the same thing. This is a little bit more of an opinionated design where, because you're doing these iteration passes and you're choosing these hyperparameters, this is just you engineering a solution to a model that's already trained, right? Which might be fine, but the paper reported that there is a negligible loss in these cases, and the benefit obviously is a strong speed up. It feels like there's a lot of situations in which even a negligible loss is not desirable for these model vendors. Like when we're really trying to reach SOTA performance across the board, even a 0.1 or a 0.2 difference across the benchmark tasks really feels to matter. Like that can be the difference of you crowning a new frontier architecture that everyone's going to try out and switch to, or you just being exactly where the middle of the pack is. So there's a part of me that feels like, yeah, it's negligible, but I would almost be more interested in architecture that combines a little bit of train time identification of what those hyperparameters should be and like train the architecture to be aware of this technique.
Do you know why they didn't do that?
I don't.
Yeah, I don't know either. Yeah.
Yeah. But it feels like that would be stronger. Maybe they wanted it to be more generalizable. Like this can literally apply to any trained diffusion model, which means that it might gain broader adoption because it's just easier in practice. But yeah, I wouldn't put money on this having staying power, just vis-a-vis if there are trade-offs, and the trade-offs are a little bit hard to quantify without actually benchmarking the model. It's not just a pure linear algebra reduction. It feels like at that point, you should just embed some of those trade-offs natively within the training process instead of having to figure this out after the fact.
Right. Right. No, I agree. I think that training it would make a lot more sense. I'm actually surprised that they didn't explore this too much. Yeah. I mean, the overall mechanism that they're using here seems to be the right one. It does make sense that you would want some sort of a heuristic that is trained, that is a parameterized approach to predict when do you want to refresh. I think that's great. Now, the fact that you'd have to train this in some clever way, that is maybe something that they were struggling with. I imagine that they ran these experiments and that they actually didn't find this to be useful, and that's why they didn't report it. It just seems like such an obvious experiment to run that it almost begs the question, why didn't you report it? And almost always the answer is because it didn't work or it worked less well than we wanted it to. And then you, as an academic, have the choice. Do you say that or do you not say that? They obviously didn't say that in this case, and that's maybe concerning if they did run it. But yeah, I mean, I would hope that more people experiment with this. I imagine that there's going to be some way that you can train this parameterized approach to make diffusion models more effective. Just feels pretty obvious.
Yeah, there's got to be something.
Yeah.
Maybe they're saving it for a follow-up paper.
Yeah, maybe that. That could be the optimistic framing of it. Yeah. That it was so good that they had to save it.
Nice, man. Well, I think that basically covers the news for the past week. It was a slightly slow news week, but I think that's nice because it at least gave me a chance to catch my breath after what I feel like was a very busy September and October
for sure.
of model releases.
Absolutely.
Plus, it's Halloween this week.
It's Halloween, and then the week after we got EMNLP, so it's going to be a ton of news. So maybe a nice little breather.
Good point. Good point.
Yeah.
Well, hey, take that breath while we can, and we'll be back to it next week.
Sounds good, amigo. All right, man. I'll talk to you soon.
Amazing. Good to see you, buddy.